We have been given a clean de-identified data set containing a sample patient readmissions data for January 2015 through January 2016. Each row in the table contains a patient and a readmissions flag where that patient's been flagged for 0, they weren't readmitted, or 1, they were. All causes of readmission are considered for this model. So it's not separated by time or condition, it's all cause. The data contains 42 different variables and health markers and comorbidities, and they've all been included in an age cohort. Our client wants us to produce a model, statistical predictive model, and to output a target list that we think are that have a highly predicted probability of readmission. And we're going to use that model, we're going to monitor it in production over the course of a year and see how it affects the readmissions rate. That's what we did. We have a lot of experience with this. We have a long line of successes in this field. We have a number of staff with years of experience and some of the preeminent and most highly recognized developers nationwide. But I'm going to demonstrate the SAP Predictive Analytics tool and how it can be used to model the data, monitor the data, visualize the data, and reduce patient readmissions. This is the home screen for SAP Predictive Analytics, and on the left side you have the data manager where you can create data manipulations or data prep work or perform an event log or sequence analysis. Like if you had a data set that had patient visits and you wanted to model what they came in for over a series of time, you could do that. The text analysis would be if you had a data set that had doctor's notes in it, notes about a patient visit, and you wanted to model that. So what you do is use your text analysis to take those text fields and break those out by their unique components into columns for further analysis. We're going to use the automated modeler. We're going to create a classification regression model. A classification model is if you're going to model a finite set of values like yes, the patient was readmitted, or no, the patient was not readmitted, and it's going to be a probability. Regression, we're not going to do that, but if we were, it would be like claims amount. So that would be 0 to positive infinity, a continuous amount. The classification model that we're going to do is yes or no, the probability. We've put an Excel file in. This is the all-cause trained data set, and that's our readmits data. You could use a data manager like an Access file or another SAP tool. You could use flat memory like SAS files or CSV files or text files if you wanted to. We are going to use an Excel file today. If you click Next and analyze the data, what this does is takes all the variables in this data set. There are 42 of them listed here, and what it's done is it's assigned numeric or text values to it. It could be a date value, it could be other, but the tool does it for you. You don't have to have a data expert sitting down and doing tedious work on metadata here. This tool does it for you. The value, continuous or nominal, that takes unique knowledge to get that right. This tool does that for you. We've assigned the key to the patient ID, and what that's for is when we create our chase list, we're going to use that patient ID. All the patients that we predict are going to be readmitted, now we have their patient ID and who they are, and when we add new data in as new patients are coming in and we apply this model to new patients, it's going to keep that patient ID intact. So we have our targets. For as long as this model is in production, we're going to keep that patient ID. And we're going to tell the model to model this all-cause readmissions variable. We're going to exclude the patient ID from the model. You don't want to model a unique identifier in a statistical predictive model. We're going to tell it to compute a decision tree, and we're going to enable auto selection. And what enabling auto selection does is it takes that readmits variable and it automatically selects the variables in this data set that correlate most with that target variable. So it's going to output the best variables that are going to predict a readmission. And you don't have to have a statistician sitting here doing this. This tool is going to do it for you. So you can use your existing staff, and you can produce models, and you can derive insights from your data using this tool that you probably weren't able to get before. And we're going to generate the model. That was a live demonstration, so you can see that happened very quickly. It chewed through all that data very quickly with good results. At the bottom, you see the selection process, selected iteration. The selection process is how it goes about selecting the predictive variables, and then 0.97 predictive power is very good. Anything 1 would be perfect, so 97 is excellent. The confidence is how well the model is going to do outside of the data set. So on new data that comes in, and anything over 0.8 is good. 0.86 is very good. So we know that we can rely on this model on incoming data for benefit. So we're going to apply that model to a test data set that has the same variables, but it's different data. You could use any data type, a number of data types you wanted. Our generation options, we're going to tell us to generate a decision. The decision is no, the patient won't be readmitted, or yes, the patient will be readmitted, or has a high probability of being readmitted. And we're going to call that output our chase list. And this decision screen here is our model, our application diagnostics. And so we don't have any false positives in here, which is good. That means that we're not going to target patients that won't be readmitted thinking they will be readmitted. In this case, you can set those options to, you can tweak that to be a little more aggressive if you wanted to, or less aggressive if you wanted to do that as well. The threshold is saying, I'm going to choose this percentage of the population, or this percentage of the detected target, or if you wanted the score threshold, if you wanted to create a risk score, this has a risk mode in it. You would have chosen that back with your auto selection. And what the risk mode is you can assign risk scores to incoming patients. But we didn't do that. That'll be in another demonstration. If you want to come back, we'll demonstrate that. And what this has done is it automatically has assigned the best confusion matrix to this model. And if you click next, this is our chase list. So you change the number of, this is a view, so what we did, we changed the number of rows we wanted to see. And these patients here that have been assigned a 1, that's our chase list. So this one's saying that the patient that has a 1, we're 99% sure that that patient's going to be readmitted. You could tell this to show all the rows, but we don't want to do that. We're just going to show this number of rows to demonstrate how it works. And you have a number of, you have some statistics and graphs if you wanted to see those. We've applied the model, we've selected the variables. You save this, you can save it and export it. As you can see with the automated model manager, this is all black box, so you don't really know what's going on the inside. If you wanted to if you had a more robust data scientist on your staff or a statistician, then you could use expert analytics to create advanced visualizations or advanced models. Or if you wanted to use R, you'd use expert analytics for that, which is what we're going to demonstrate now. What we're going to do is demonstrate the SAP Predictive Analytics Expert Analytics tool to model your all-cause readmissions patient data. And if you've used SAP Lumira before, you might see some similarities here. When you open up the package, you'll see on your left side, your left pane, you've got your documents and visualizations, data sets, and stories for storyboarding. And you've got your access to your Lumira Cloud and Lumira Team Server and the SAP BI platform. You can also create custom connections for other data sources, access files, and flat memory, SAP, or SAS data sets. We're going to load in our Excel all-calls readmissions file that we've added into a document, the all-calls readmits document, for demonstration. So when we open that, we get, you can see this interface looks quite a bit different than the automated model manager did, because your insights, you can get more custom insight from this. So you can show your grid that shows what your data actually looks like, or you can show this view, which is showing the levels in your data. So if you can make short work of data prep this way with this view. You can show your columns, so you can actually select which columns you want to show. If you want to get rid of columns, you can do that here. I'm not going to do that. But moving on into this Predict tab, this is where you create predictive models. And what I've done is created an R classification and regression tree. If you have a more robust data scientist in your staff, that knows R, you can utilize that person to write R scripts, and then you can put them in here so that somebody that's not as robust in R or not as robust as a statistician, you can put those models in here to visualize. So it enables collaboration among your staff. If you don't have a data scientist, though, you can still get benefit from these predictive models, because SAP's included some automated models that you can choose. Over here you got prep. You can write your data out if you want. When you build your model, this is how you would export it. You can load in, so that you'd use this part to import models, or you could import, so from your automated model manager, or you could import R extensions or R components using that. And SAP actually has an extensions website where other folks create R packages for their tools. You can go up to their extensions website, and actually you can customize this tool using other people's R analytics or analytics. So it creates a much more collaborative environment. It's really neat. I'm going to do that in another demonstration. If you want to come back, I'll demonstrate how that extensions website works. This decision tree that I've created, this is what that looks like. And the R code is it's in here. And don't be intimidated. You don't have to do this if you don't want to. This is what your confusion matrix looks like, and this is what your decision tree actually looks like. This is neat. If I wanted to create this and show this to somebody, it doesn't take a statistician to understand this decision tree. At the top, you've got your root node, your yes or no, readmit or not. And going down your left side, if they've been to the ER less than 1.5 times. On your left side, you've got not readmitted. On your right side, you were readmitted. So if you've been to the ER less than 1.5 times and you were discharged to ECF, home health, or LTAC, you continue down the chart. If you were released to rehab, then you're going to be readmitted at a high probability. Continuing down the chart, if you were released to LTAC or SNF or SELF, and you're in this age cohort, then you've got a good probability of not being readmitted. If you were, then you continue down, and finally you come down to your COPD asthma at the very bottom. And if you don't have COPD asthma, then chances are you weren't going to be readmitted. And you can see each of these represents one patient. So a patient only shows up in this tree one time, and these are how the decisions take place. I'm going to now show how the visualizations work. This is on the whole data set. In this part, you don't have to be, you can be a good analyst. You don't have to be a trained data scientist to get benefit here. This pie chart, if I want to see what readmit patients, this is what their BMIs look like. So of all the readmitted patients, half of them actually had a low BMI, I find that interesting. I would think that high BMIs are going to be readmitted. That's not the case here. And what I've done is I've composed these charts. So our client asked us to create advanced visualization and create a model for readmissions. So our client doesn't want to see everything. They just want to see what is compelling to them. So what I've done is created a storyboard called Composition of Readmits. And here you see the patients these were readmitted patients, and this is where they were discharged to. You had your highest instance of home health, but second, SNF and self discharges. This is the payer, so if they went in and they had commercial insurance or dual insurance, Medicaid or Medicare, this is the composition of readmits, and Medicaids have the highest instance of readmit, followed by Medicare. And this is the age cohort of readmits. This is interesting to me because your 35 to 39 and 70 to 74 age groups have the highest instance of readmits. The 35 to 39, I find that interesting. So you keep going, and these are readmissions by composition of comorbidities. So along the bottom, you see if you 1 through 4 comorbidities and which comorbidities they have. So you can see the patients on the far left, in that far left column, those COPD asthma patients only had one comorbidity, but they were going back to the hospital quite a bit. And that 3 instances of 3 comorbidities, those diabetes with the high instances, they had 3 comorbidities. They had multiple comorbidities, and they were going to the hospital a lot, which correlates with cost. Diabetes patients contribute to the highest cost, but not necessarily the highest readmit, as we will see in these next graphs. So we've got the predicted probability. This is the correlation between COPD asthma and your predicted probability of readmit. And as your predicted probability of readmit goes up, so does your COPD asthma. Here's the correlation between smoking and readmit. It's quite compelling. As your predicted probability goes up, so does smoking. That's your correlation. And finally, you monitor. So you put this model into production, and what you do is you monitor your readmissions rate throughout the year based on a mean and a standard deviation chart. And you have your upper control limit and your lower control limit. Those are thresholds. So you think that somewhere in the middle between those two lines is where your readmissions are going to be, and your upper control limit that's your maximum threshold for readmits, and your bottom is a function of standard deviation. Your lower, you don't think it's going to get lower than that under normal conditions. So what the readmissions rate, you can see that by putting this model actually into production, you started out in January 15 above your upper control limit, so you had a higher readmissions rate. But actually, as the year progressed, your readmissions rate went down, and we actually got, by having this model into production for a year, we were actually below the lower control limit. So we will demonstrate the whys and hows of that. That would be in a different demonstration where you can share this with other people. So you can take this and you can publish this to File or SAP HANA, or you can put this on the Lumira cloud or the Lumira server, or Streamworks. So it's this expert analytics tool. All in all, if you are a robust data scientist, you can use this for custom R components. If you're not a data scientist, you can still use the expert analytics for data manipulation and prep work, as well as presentation quality visualizations. And you can collaborate your data scientists with your analysts by importing and exporting models and sharing the data. And with that, that concludes our demonstration of the SAP Predictive Analytics software tool. And this is Barry Reese signing off. Thank you.